ছাৰ আহিছে আপুনি
হেল্ল' সুৰজিত শুনিছা
ছাৰ আহিছে আপুনি মই মানে মিউটটো মোৰ হাতত আছে মিউট
এতিয়া শুনিছা নে
শুনিছো ছাৰ ঠিকে আছে ছাৰ
ওকে
Dear participants, as the resource person is not joining yet, so kindly wait for 2 or 3 minutes. Thank you.
Good morning, Deb.
Good morning. Good morning.
Good morning. ভাল লাগিছে দে দেখি।
ভাল। Program start কৰিব পৰা হৈছে না?
সুৰজিতে কৰিব এতিয়া।
Yes.
সুৰজিতে কৰিব। সব ঠিক আছে তো?
খুব ভাল ইনিশিয়েটিভ গড়গাঁও কলেজৰ। প্ৰথমতে কংগ্ৰেচুলেশনস।
Thank you. মই সুৰজিতক কৈছো দেব মোৰ বন্ধু হয়।
একে ক্লাস।
May I start now, sir?
Yes, you can start.
Good morning, everyone. Respected Principal Sir, Dr. Saibasasi Mohanto, Gargaon College, Professor Kumar Chakraborty, Sir, Department of Economics, Dibrugarh University. Today's resource person, he's the today's resource person. Faculty members from different universities and colleges, and my student friends. On behalf of the organizing committee, I, Dr. Surajit Soikia, Assistant Professor, Department of Economics, would like to welcome you all to this workshop on data analysis in social science research. So at first, I would like to request our principal, sir, to inaugurate the workshop. Thank you, sir.
Very good morning to all. Thank you, Dr. Surajit Soikia. The Gargaon College has been continuously organizing some webinars and workshops in the time of lockdown, so that in the time of lockdown also, with the help of online facilities, we can continue some academic activities. This is an endeavor of Gargaon College to organize an one-week workshop on data analysis in social science research that has been organized by our Gargaon College in collaboration with the major research project sponsored by ICSSR, and that has been awarded to Dr. Surajit Soikia, Professor in the Department of Economics, Gargaon College. And I would like to welcome our resource person, Professor Kumar Chakraborty, Department of Economics, Dibrugarh University. It gives me immense pleasure to welcome Dr. Kumar Chakraborty, as he is my classmate. We studied together in Prof. And another research person is there, Dr. Kumar, is an independent and visiting faculty, and also the founder of Research Shiksha. As we all know, methodology is most important in any research work. For doing a research, the methods are most important, and data collection and data analysis is another two components of methodology that is that are most important for social research, so that we can come to a conclusion, we can arrive at a conclusion. And there are certain methods of data collection and data analysis. After data collection, the data needs to be critically analyzed. As we know, data analysis is very important, as it provides an explanation of various concepts, theories, frameworks, and methods that has been used in particular social research. And it is a part of empirical study and helps in arriving at conclusions. So we have our resource persons. This workshop would be an one-week workshop, and I hope this would be it would be helpful for our students as well as for research scholars, young research scholars, and our faculty members. I would like to welcome you all. I would like to welcome our resource person, Professor Kumar Chakraborty, and Dr. Ajoy Kumar Chauhan, all the participants, faculty members, and students, and hope this would be a grand success. And at the same time, I would like to take the opportunity to thank Dr. Surajit Soikia and Nilutpal Chutia, the coordinators of this particular webinar, and Also our members and technical support staff, Dr. Dimbeswar Das and Dr. Pankaj Kumar Nath. For their help only, we can organize such a beautiful event on behalf of Gargaon College. And I hope this would definitely helpful for all the faculty members and students and young research scholars. And with these few words, I would like to welcome you all, and I would like to declare the 1 week workshop on data analysis and research is open. Thank you. Thank you, Surajit.
Thank you, sir, for your time and your inauguration speech. Now I would like to introduce today's resource person, Professor Dibrugarh Chakraborty, sir. Professor Dibrugarh Chakraborty, sir, is the professor, Department of Economics, Dibrugarh University. Now, sir is acting as coordinator to UGC Major Research Project, Center for Studies on Bangladesh and Myanmar, UGC DRS Phase 3 Special Assistant Program, Department of Economics, Dibrugarh University. Sir has completed 5 major research projects, 1 minor project, and Sir has also completed 2 consultancy projects funded by Institute of Rural Management Anand and All India Limited. Under his guidance, 9 numbers of scholars have got degree. His area of specialization is econometrics and mathematical economics, and he has worked in the areas like industrial economics, labor economics, financial economics, tourism, etc. Sir has lots of publications in both national and international reputed journals. He has got more than 50 citations from different scholars around the world. He has got ACE index, ITAN index. So anyone want to visit his works, they can visit Google Scholar. And we are very happy to have a resource person like Dibrugarh Chakraborty, sir. So today, hope his deliberation and your active participation will make this session a successful one. Thank you, sir. Once again, I welcome you to this webinar, to this workshop on data analysis in social science research. Now, I would like to hand over this session to you. Now the session is yours, sir. Thank you, sir.
Ready to unmute Korea?
Yeah.
You are audible now, sir. You are audible.
Yes. Will you allow me to share my screen?
Yes, definitely, sir. Wait. Now you can share, sir.
Okay. Is my PPT visible?
Yes, it is visible to all, sir.
Okay. So good morning to all of you, respected principal of Gargaon College, organizers of Gargaon College, led by Dr. Surajit Sarkia, and all faculty members of Gargaon College, esteemed participants, and other listeners. In fact, it is a good opportunity on my part to share some of the things with you, particularly with reference to data analysis and how we go for collection of data as well as go for analysis of data and a bit of presentation. I will not discuss, because this is such a broad topic that we cannot cover up all details within a very specific time frame, but I will try to cover up the areas where we should get ourselves sensitized. There are some areas while we deal with data there are some gray areas where we'll have to be extra cautious, and we will have to be statistically very sensitive, or econometrically we'll have to be a bit sensitive in dealing with such areas. So I will try to cover up those areas in greater detail, the caveats or the warnings of data analysis part. So if we try to understand data, then it can be, or analysis of data, it can be a kind of definition that you have your own definition. You can frame your own definition, like the blind man and an elephant, the Indian fable or the story that we know, that if you allow some persons who are visually challenged, they can define the elephant from different angles. I mean, someone can define the trunk by saying it's a long pipe or like that. Okay? So in that way, data analysis can also be defined in different understandings. We can have our own understandings, and we can have our own narratives, and accordingly we can have our own views of data analysis. But see, there are some facts. Data is data. I mean, you just can't change it. I mean, like my age, my income, or the marks of the students of a particular college. These are data. These are real things. Now, data are always collective insights. So I mean to say that single data, if I tell you that my age is 65, then directly we cannot frame many insights out of it. If you don't know the average age of persons, if you don't know how many years an average person can survive, all these things if we do not know, then if I tell you my age is 65, then we cannot infer insights out of it. Suppose a student get 85 in a particular examination, then immediately we have in our mind that the maximum marks is 100 and the minimum marks is 0. Then we can get some insights out of it. So data are always collective insights. Sometimes it can be a single digit, single number, single data point, but still we have in our mind many data in our system, and then we draw the collective insights. So this is very vital. So understanding data, the philosophy of data is more important than collection of data or doing some research on data. Because if we have more collective insights for a particular data set, that will give you more understanding, more interpretation. There is more space for interpretation. The second is data provide a trace of time. Always data has, it can be a time series data, or it can be a different type like cross-section or panel. It always provides a trace of time. We have some kind of time dimension attached to it. Even in case of cross-section data, when we collect cross-section data at this particular point of time, so we always refer a particular time point. And data gains significance through association. Association means if we can associate a particular variable with another variable, then that gives you a better insight in drawing the inferences. Now, there are different types and sources of data. Now, what are the types? There are many, variety different types of data. First one is time series data, when data is arranged with reference to time. And then we have cross-section data, when we collect data for different cross-sectional units for a specific time period. And then we have panel data. Then we have some other kind of data, like we have data from, say, social media. Nowadays we have data called big data. We have data called large data. So we have data of different types. Now, when we talk of the sources, then sources are also not the stereotype sources, the sources that we had to study in our statistical texts. Now, the sources of data, these are also that scope is being enlarged. Earlier, the sources of data were, say, government reports, government documents, then your primary survey. You can go for canvassing your schedules and questionnaires, and then direct personal interview or indirect interviews, telephonic interviews and all. But nowadays, the sources of data is expanding like anything. Now we can collect data from social media. We can collect even out of your own purchase behavior in an in-network place. We can collect large data set. So data set is now the sources of data is now being enlarged, and the scope is being enlarged. Now, why do we analyze data? This is very important. See, we have to analyze data because we want to describe and summarize the data. Simply, if I tell you that there are 100 data points, say marks of my students, 100 students are there and the marks are like these, then that does not tell us many things. What it doesn't tell? The first thing is this: what is the average mark? It also doesn't tell what is the variability of the students in terms of their performance. And then it also doesn't tell us that what will be the average level of performance in terms of the society at large, or the state level or district level or something like that. So we will have to describe out of the data point, and we want to summarize the data point. So that is one. Then we want to identify the relationship between variables. We have, say, rainfall and we have production. So if you try to keep the data point of rainfall separately, and if you try to keep the production data set separately, then it does not speak the whole story. Then if we want to build the story, then we will have to link these two variables of production as well as rainfall. So that kind of a relationship can be viewed in terms of correlation, in terms of causal relationship, or in terms of grander causal relationship in time series data. So three different types of relationship we can think of. One is simple relationship in terms of correlation. We can think of some causal relationship in terms of regression, and we can think of some grander causality in terms of vector autoregression or some other kind of things. So we want to always build up some kind of relationship between variables, and that's why we need to analyze data. Then there is the need for comparing the variables. Say we have two sets of students. One is, say, one set of students who have gone through some coaching, and another set of students who haven't gone through coaching. Now we want to see whether the performance of the first batch is different from that of the second batch. So we want always to compare the variables, mean marks of the students who have undergone coaching and the mean marks of the students who haven't undergone coaching. So we want to compare the variables, and accordingly we have to analyze the data. Then identify the difference between variables. There are so many, and we always try to see whether this particular variable is different from that particular variable. And then obviously one more important things coming day by day is forecasting, or we want to predict what will happen in future, particularly if we want to deal with reference to price or with reference to Sensex data. We want to forecast the outcomes, what will happen tomorrow's sensitivity index, or what will happen to the inflation rate, or what will happen to the price level, or so and so forth. So these are some of the things why we basically analyze data. Now, data can be interpreted in different ways. Now, what is interpretation? Interpretation is the process of attaching meaning to the data. Data itself does not speak. I mean, my age, say for example, my age is 45. Now, it doesn't speak anything unless and until you have a proper interpretation of the data. So how can you interpret my average age? My age can be interpreted. What is the average age of the people of Assam? What is the life expectancy of people of Assam? You can have no different kind of analysis out of it. Okay, so now what is the retirement age of the persons in Assam? So you can have a different interpretation out of it. Now you can have your own interpretation. You can build your own interpretation depending on the objective of research. Now, very importantly, we have different scales of measurement because we have to measure the data. Now we have nominal, we have ordinal, we have numerical scales mostly. Though we have another scale. Mostly we have nominal, ordinal, and numerical scale. Numerical scale is very simple. When you ask my age, my income, my performance in examination, this comes up in numerical setting. Okay, ratio variable. If you ask me what is your age, my answer will be 45, 46 kind of thing. Now, when we want to look into some variables which are not in ratio format, but you can have some categories. But you cannot rank the categories. Those cases are
Sir, you can proceed.
Yeah, sorry, so some kind of. Okay. Is it proper now?
Yes, yes, sir.
Yes. So now there are some variables which can be categorized or which can be placed in different categories, but we cannot rank the categories. So, for example, which of the following newspapers do you read? Now, say newspaper 1, newspaper 2, newspaper 3. We cannot say that newspaper 1 is better than newspaper 4. So that is not there. But what we can say is this. 1 minute, please. So what we can say that we cannot rank the categories. So that particular variable is nominal variable, and that scale is nominal scale. But in ordinal scale, we can rank the categories. The variables can be ranked ordered. Say, for example, how many days you visit the gym? Say 1 day of the week, twice in a week, thrice in a week, 4 days in a week, like that. Now you can rank the order. If you select the third option, then that is better than the first option. If you select the fourth option is better than the first option. Such kind of thing. So we have another kind of variable where we have dichotomous choice, either or, this or that, male, female kind of thing. So that is an kind of nominal variable where we have two options, but you cannot have these and that, like yes and no kind of thing. Now, what are the advantages of quantitative data analysis? First, it allows researchers to focus on a wide variety of subjects, and ultimately this helps greater generalization of the results. Now, wide variety of subjects mean, if I try to see what are the factors that are determining the productivity of Indian agriculture, or say Assam's agriculture. Now, there are many factors that will have kind of interactions with reference to the productivity of Indian farm. Now, if we don't have a kind of quantitative analysis, then we cannot possibly cover up all those kind of factors, like labor, capital, raw material, and so on and so forth into our analysis. It becomes very difficult. So if we want to focus a wide variety of subjects, and ultimately if you move to quantitative analysis, then everything can be clubbed and we can come to a proper conclusion. The number two, results are more objective and accurate in comparison to qualitative.
True color beneath.
Yes. Now, results are more objective in the sense that, say, for example, if I run a regression, that what are the factors that determine the productivity, then we can count very accurately, very precisely that these are the factors that determine the productivity of Indian farms. And accurately we can say, because we have kind of statistical techniques that will tell us that how we can infer out of the data set. So that kind of things are possible, but in case of qualitative data analysis, that much of precision and that much of objectivity may not be present. Now it can review wide range of information and enable researcher to compare and contrast among different groups over a long period of time. Sufficiently, we can, particularly in case of panel and time series data, we generally take a very long period of time, and we want to compare what is happening with reference to this particular data set and that particular data set. And in quantitative data analysis, the researcher is usually unknown to its subjects and keep distance from the source of data, so personal bias can be avoided. Now, it's not that suppose that if I give you the data set of BSc Sensex, and if I give you the data set for NSE, then possibly you can have some understanding of BSc, the volatility of BSc index and volatility of NSE index, but your personal bias will obviously not present there. So no personal bias, everything can be avoided by looking into the quantitative data. Now there are some shortcomings. To ensure greater level of control over subject material or subject content, researchers often carry their study in an unnatural artificial environment which might be inconsistent to real world results. So for example, if I try to look, particularly social science, this is absent, but still, if I look into the productivity of a particular farm, which has been carried out in a very artificial environment, and that data has been generated in an artificial environment, that may not be consistent in the real world kind of thing. So that is one lacuna of it. If I ask a person who is a very kind of outlier, who doesn't fit the whole general population, then obviously that will not fit the data set well. That quantitative data analysis is criticized for its nature of focus on much narrower and often hypocritical data set analysis. The data set, the focus is very limited. If I tell that this is the average income of the people of this locality, then that's it. I mean, it does not speak anything beyond that. But in qualitative data set, qualitative analysis, the story doesn't end there. Story begins there. You will have to look into that why that happens, why is it real, or where the income goes, or so many questions will have to be answered there. But in quantitative data analysis, probably mean income is enough because that is your target. Then standard questions can lead to structural bias and may not reflect actual perception, but closet math of it. So for example, we sometimes put the questionnaire in such a way, or the schedule in such a way, questions in the schedule in such a way that some structural bias may be included in the whole data collection mechanism itself. Now, if you have that kind of structural bias, it may not reflect the actual perception of the person from whom I'm just collecting the data. Now, one particular problem that normally we encounter in practical research is that we straight away go to the collection of data and then we want to summarize the whole findings out of our analysis of data like regression and something, and then we keep on writing the report. But first and foremost thing of data analysis is that we should have a theoretical foundation in our mind. What does theory tell us? Say for example, if I am looking into the productivity of our agriculture, then obviously we will have to first look into what does theory tell us. Say for example, you have production function analysis. It speaks that production is a function of labor and capital. It also speaks that production is a function of, say, labor, capital, and raw material. Then we can just elongate it. We can just encompass some more variables into it. So then comes what is the architecture of that relationship, whether it is a linear, whether the variables are linearly related, or variables are related in a different fashion, say for example semi-logarithmic, or say different functions you can think of. So that kind of theoretical foundation is a must, and that gives you the beginning block of data analysis. The second is hypothesis formation. If you do some kind of mistake in formation of hypothesis, then your analysis part, data analysis part, will be misleading. Say for example, we generally now what is hypothesis? First let me just give a proper understanding of it. Hypothesis, hypo means less and thesis means truth. So anything is less than truth, say it's a proposition which is subject to verification. Now what happens if you combine so many things in a particular hypothesis, then it becomes difficult on our part to accept or reject, because hypothesis is a statement which is either accepted or rejected. There is no possibility of doing in between kind of thing. So say for example, you are saying that x1, x2 and x3 determine y. Now you will appreciate with me that x1, x2, x3 determine y is not an hypothesis which is defined very properly. Because one thing of hypothesis, one characteristics of hypothesis is that hypothesis should be clearly stated and there should not be any ambiguity. Now, if we look into x1, x2 and x3 that determine y, suppose at the end of the day, you find that x1 determine y and x2 does not determine y, then what will happen to that particular hypothesis, hypothesis number 1? So it will become very difficult. So hypothesis framing is an art as well as science, and we'll have to frame the hypothesis, both the null as well as alternative, in a proper perspective. Then we'll have to look into what are the tools of analysis that are there in our disposal. Now, tools are many. We can start from correlation. You can have some descriptive statistics. You can have a simple. You can look into the mean of the variable. You can look into the standard error of the variable. You can look into the standard deviation of the variable. You can look into correlation. You can look into regression and whatnot. We can jump to some more important kind of analysis out of the data set. So, understanding the tools, what kind of tool we are going to use and what are the preconditions for using the tool is very important. Sometimes what happens, we do not look into the preconditions for using the tools and abruptly we use the tool. So that will give you misleading results. So for example, I'm just giving you one example. Chi-square test is often used in social science research in understanding the association between attributes. Now, there are some conditions which must be fulfilled in order to apply the chi-square test. Say, for example, your expected self-frequencies cannot be less than 5. That is one assumption of chi-square test, the validity of chi-square test. Now, if your expected self-frequency is less than 5, then you cannot apply that particular tool of analysis. So ultimately, whatever tool we use, that tool should be tested and we'll have to critically examine whether that tool can be applied and whether there is sufficient ground for applying that particular tool under the guidance of your theoretical analysis. And then comes the estimation part. Estimation part, say estimation is something where you use a particular estimator and get some kind of estimates. So that process is known as estimation. And in the whole process, what will happen? You can apply regression as a tool for estimation. You can go for even simple estimation technique. If you calculate mean, that is nothing but estimation. You are using an estimator. Simple arithmetic mean is an estimator. So all those things lead to the process of that is the whole process of estimation, and that will lead to a kind of estimates. So in the estimation, the most important thing is to locate the estimator. Very importantly, one will have to judiciously look at the estimator. Sometimes arithmetic mean may be an estimator, sometimes median may be an estimator. Sometimes we're looking into the variance, some kind of variance may be so some kind of variance may be like standard deviation may be one estimator. And in standard deviation also there are say two different formulae. One is root over 1 divided by n summation of x minus x bar whole square, and another is root over 1 divided by n minus 1 sum of x minus x bar whole square. Now one is 1 by n and another is 1 by n minus 1. One is biased estimator, another is unbiased estimator. So how to select the estimator? So you have got the different guiding principles of selection of the estimator. What are the guiding principles? We will have to select that estimator, the estimator which possesses the desirable properties of the estimator. What are the desirable properties? Desirable properties of estimators are unbiasedness, linearity, then minimum variance, then estimator should be sufficient. All these things are desirable properties of the estimator. So we will have to look into those things first, that what particular estimator we will select, because everything depends, your result depends on the estimator, and all estimators are perfect, all estimators are good, but maybe say you have two estimators and possess the desirable properties, but in a particular context one particular estimator may be useful. If you remember Human Development Index, then in Human Development Index we use geometric mean instead of arithmetic mean. Why? Because that's a big question that has to be answered. Why we do not go for arithmetic mean of 3 parameters, 3 index, but we go for geometric mean? So this kind of articulation, this kind of argumentation is very important, that why we select a particular, say in Human Development Index we go for geometric mean, but while you ask my marks, we go for arithmetic mean. We do not go for geometric mean. We never say that my average mark is in terms of geometric mean. So we will have to look at the estimator in a particular context. So that context will have to have some theoretical understanding and practical reasoning. So in HDI, that has come from some theory as well as practical understanding. So we'll have to look at these things. Now, my whole, my lecture will center around the caveats. What are the caveats? So first is the omission of some important indicators might create a whole lot of, trouble. One is, now what are the important indicators that may be omitted? So for example, if we are interested in income of the respondents, then maybe we have omitted some of the things which we have not taken care of. Maybe we are interested in productivity of a firm. We have not taken the variables which should have been taken care of. So we will have to locate all the important indicators, all the important variables that we should have been included. See, if this happens in case of a regression analysis, that will lead to some kind of bias. If we doesn't include the variables which should have been included, then that will lead to specification bias. But if we fail to collect data for some important indicators, then that will obviously lead to different kind of problems in the later stage of your data analysis. Say, for example, you should have collected data for raw materials, HYV seeds, say for example, you have not collected the data for HYV seeds. Now, while you frame a regression, you don't have the HYV seeds, the variable for HYV seeds, the data for HYV seeds. So ultimately what will happen, production depends on some other factors, but not on HYV seeds. That will lead to model misspecification. Model misspecification will lead to several problems. One major problem is that it will lead to bias estimator. So this is one of the problems that we will have to look into, the omissions and some deletions of some important indicator whether that have taken place. The second is reporting too many pieces of information. sometimes generally what we feel is that in a research paper, if you just go through, then first of all you get the summary statistics. Now, summary statistics is generally reported in a particular table comprising of the mean and standard deviation or variance of or coefficient of variation of all the variables that you have at your disposal. But sometimes what happens, those informations are not relevant for your study or for your further data processing of further data processing. So you will have to look into what are the main interests of your study, what are the main objectives of your study, and whether those things are required or not. And similarly, it also happens that we report too many decimals in case, particularly in case of test variables. In say for example, in case of the probability value, p value, we report so many decimals. I mean digits after decimals. So these create kind of information which is redundant sometimes and which becomes absolutely very difficult to comprehend. Then incorrectly performing statistical procedures which are not suitable for a particular set of data. Say calculating Pearson's product moment correlation coefficient for data given on ordinal scale instead of using spaceman correlation. So we'll have to understand what particular statistical intervention is required for what set of data. You don't have a kind of ratio variables, you don't have the sets of ratio variables, but you are using Pearson's correlation coefficient. So that will give you some kind of misleading result or obviously no result in many cases. So your statistical intervention should be suitable for a particular set of data. So what kind of statistical intervention is required, what kind of procedure you are going to perform will always be guided by a particular set of data, what you have. Say for example, if you like to have Granger causality in cross-section data, that will be misleading. If you like to have OLS in time series data, that will be misleading. So depending upon the statistical data set, your statistical interventions in terms of your procedures that you are going to follow will depend. Then misrepresentation of results of the study is another problem. Sometimes what happens, we generally get this kind of thing. Suppose you have 5 districts and production of 5 districts. Now you have represented the districts in x-axis and production on y-axis. Now what happens? You have different points. Now someone may, instead of drawing bar, would like to put a connecting dots line diagram. Now what is the implication of it? It will imply a wrong thing, because that will mean that in between, say, Jorhat and Sibsagar district, some other district is there. So that is misleading. Misrepresentation of results. So result is correct, but you are representing it wrongly. Similarly, it happens in case of regression result or correlation result if we don't know how to represent the result. One simple problem with correlation study is this: we do not give the level of significance or the p-value, we do not represent. So ultimately, that is not the correct representation of results. Simple value of correlation coefficient is not enough, or simply reporting the value or estimated coefficients of the regression is not enough. Then another point of warning is that wrong data entry might happen, and it normally happens if you are handling a huge survey, large survey. Then you are dealing with large number of questions, and you are going to enter all the data set into your statistical package or something. So there may be wrong entry of data. One warning is there, and ultimately we come up. So normally what happens for the researcher, it is suggested that whenever data set is entered, always look into the frequency table. Come out with the frequency table of that particular variable and look that what are the values. So if suppose say your data set is in terms of Likert scale 1 to 5, 1, 2, 3, 4, 5. Now, while entering data, in some cases, 4 and 5 came together in a particular value. So it will be 45. So now that mistake will not be counted in the beginning level. So what is suggested, you will go for frequency table. If you prepare a frequency table, then you can look at that there is a mistake. A particular entry is showing 45. So that kind of corrective mechanism can happen in case of your age also. In entering age, suppose a particular value comes up only 1. Then if you carry out a frequency table, then you can look that that particular variable is coming up 1. Whereas your people or your respondents are all adults. So ultimately that will give you a cross check. Then important thing is you will have to look into the estimator and the indicators. I told you slightly earlier that choice of estimator is a very important point in statistics. Suppose you have OLS, ordinary least square technique, and you have maximum likelihood estimation technique. Now the question is, which particular method I am going to select? Which particular method I am going to adopt? So that depends upon your choice, obviously, your personal choice. Then obviously what the theory guides you. Then what are the objectives? What are the the desirable properties of the estimators? Whether the estimator possesses the desirable properties of the estimators, or whether your estimator is blue or not, and what are the other assumptions of that particular estimation technique, whether those assumptions are fulfilled or not in your present state. So that will guide you in proper choice of estimator. Sometimes we do a wrong choice. In many cases, we do wrong choice. Where we are to select median, we select mean. Where we are to select geometric mean, we select arithmetic mean. This is a very kind of simple thing, what I am reporting, but it may be taken into some several extremes. Like we take sometimes OLS, where we should have taken GLS, or where we should have taken maximum likelihood estimation or some other estimator techniques. Similarly, the indicators also depend. The choice of indicators also depends upon your theory, your context, your the basic assumptions of your indicators and all. Then another point is of very important, particularly for data analysis, is the parametric and non-parametric tests. We must know this difference between parametric and non-parametric, and normally this is the area where the researchers, the young researchers, make some mistakes. Say, for example, what is a parametric test? Parametric test means a test statistical distribution for which population distribution is assumed. Some form of population distribution is assumed. And normally that population distribution is assumed to be normal in case of t-test. So T is a parametric test. Non-parametric test means we don't have any assumptions for population distribution. So that is the difference between parametric and non-parametric. Now what happens when you have a parametric test at your disposal, when you want to carry out parametric tests? So obviously that assumption of population distribution should have been fulfilled. Now what generally happens, we may be interested in understanding the difference in the learning outcomes of the students having access to online material and student doesn't having access to online materials. Now you have 40 students having online access, 40 students who doesn't have online access. Now what happens if we simply calculate the mean x1 bar and x2 bar and we want to run a t-test? That is valid, we can run. T-test will tell you that whether there is significant difference between these set of students and that set of students. But there is a problem. Before running T, we'll have to ensure that the population distribution is normal. Unless and until population distribution is normal, we cannot run a t-test. Similarly, what happens in case of regression? Look at the case of regression. In case of regression, we have one very important assumption of ordinary least square is that the disturbance term follows normal distribution. The disturbance or the random term follows normal distribution. Unless and until that assumption is required only for hypothesis testing, and that's not required for estimation purpose. Now, if unless and until that assumption is fulfilled, we cannot go for hypothesis testing in a regression estimation, post-regression estimation. So suppose we have got the estimated coefficient of labor, that is marginal productivity of labor, to be 0.3. We cannot say that an increase in labor will lead to production up to 0.3, because unless and until we run the t-test, because that 0.3 may be equivalent to 0. There is no fundamental difference between 0.3 and 0. So our null hypothesis will be 0.3 is equal to 0. 0 is the true population parameter. Now after that we run t-test. What is t-test? T-test is equal to t of beta cat is equal to beta hat divided by standard error of beta hat. So that is the way by which we carry out the t-test. Now that requires basically one fundamental thing, that the population distribution is normal. So in a regression analysis, whenever we go for t, we must ensure that the data set is normal. But normally we generally do not do. But if your data set is not normal, then you go for some non-parametric test where possible, or you convert the data set from non-normal to normal if possible. So that kind of things we'll have to do. So this is very important, that we'll have to look into the tests, whether your test is parametric or whether your test is non-parametric, and accordingly your interventions will be applied. Then another problem area that researchers generally do the mistake is correlation and causation. See, what we generally do, we consider correlation in terms of causation. Now, correlation is a different thing, and causation is a different thing. Granular causality is altogether a different thing. Now, let me just first consider correlation and causation. Now, suppose A and B, we are interested in looking the correlation between A and B, and we have got significant correlation between A and B. Suppose 0.9. But we cannot say that A and B are causally related. There is a causal relationship between A and B. Why? Because of many reasons. I'll just give you one. Why? Because it may so happen that A is influencing C, which in turn influencing B. There may be some latent variable, there may be some other variables which may do that particular thing. There may be also the situation that these two are not relevant. These two, broad groups are not relevant altogether. These two are totally different, variables. Say my age and productivity in Indian agriculture. That kind of things may happen. It may also show you correlation, but that does not mean that it has a causal relationship. And granular causality, the concept is altogether different. Granular causality says which variable moves first. The variable that moves first may granular cause the other variable, but the other variable cannot granular cause the first variable. So the concept of granular causality is in terms of movement of the variables. The variable that moves first. So in that particular, so it normally happens in case of time series data. Then another very important point that the researcher should look into is the level of significance and the degrees of freedom. Now, simply, let me just first take up the point of degrees of freedom. Now, what is the degrees of freedom? Degrees of freedom says, say for example, if I tell you to give me 3 numbers whose sum total is 10, The first number you can tell me arbitrarily like 5. Second number is 3. But the last number you are constrained to say 2. So 5, 3, 2. Total is 10. Why? Because sum total is equal to 10. I have given you beforehand. So if I give you a linear restriction, what is this? This is a linear restriction. x1 plus x2 plus x3 is equal to k. If I give you a linear restriction, 1 degree of freedom is lost out of your total sample size. So degrees of freedom here is 3 is total sample size. 3 minus 1, that is equal to 2. Now if I give you a further linear restriction, that yes, you tell me 3 numbers whose sum total is 10, but the first 2 numbers sum total must be 5. The first number you can select 2, second number you will have to select 3 because sum total must be 5, and the third number you will have to select 5. So basically you have only 1 degree of freedom out of 3 numbers. Now why that degrees of freedom matters? See, degrees of freedom, if you cannot retain in a small sample, then the precision of the estimates declines. Say for example, in a class you have 100 students, and if I ask you that please give me 3 students to represent a particular contest. Now if you totally do a random experiment, random sampling, you write down all 100 students roll number and then pick up 3 students, then that will be highly representative of the class. But if I give you one condition that look, you send me 3 students, but sum total of their roll numbers must be 80. The first roll number you can select arbitrarily, the second roll number you can select arbitrarily, but the third one you will have to fix a student you will have to select. So similarly, that will not be full representation of the class. So if I repeat the exercise second time, that may not be, that particular estimate that in the first place you have got, the second time I can get a totally different estimate out of it. So the precision of the estimate get, vitiated. I mean, you don't get that kind of precise estimate. So it is of our interest in a particularly small samples to retain the degrees of freedom, and level of significance is also important because while you select the degrees of you select the level of significance and fix the degrees of freedom, then only you can get the table value. Now level of significance is very important, and we have some kind of misunderstanding about the level of significance also. We generally consider that 1% is good, 5% is bad, and 10% is worse. That kind of understanding we have, but in econometrics we don't have that kind of understanding. Say it depends upon context to context. If suppose your study is related to, say, a case of criminal. Suppose Mr. A is a criminal. Your hypothesis is Mr. A is criminal. Now, the simple law of jurisprudence, simple rule of jurisprudence will tell you that innocence should not be punished. The simple rule is something like that. So what will be your case? Your case will be to reject the hypothesis. Your hypothesis, Mr. A is criminal. So your target should be to reject the hypothesis. So your rejection reason will now be more. So rejection reason will be, I will like to carry out this hypothesis test at least at 5% or 10%. I will not go for this kind of hypothesis 1% and risk some kind of, accepting some false hypothesis. But you look into some other context altogether. If your hypothesis is drug A is spurious, so now your idea will be to declare a non-spurious drug as spurious, but a spurious drug should not be let free. So now what will be your rejection reason? your rejection region will be very, very small. So this kind of study will be accepted or rejected at a very small level of significance, probability of committing type 1 error. So that will be quite small. So I will accept this at 1% level of significance or reject it at 1% level of significance. So context to context, what kind of study that you are going to do, that will tell you that whether you will try to increase the type 1 error or you are going to increase the type 2 error. Both the errors are wrong. It is not that type 1 error is bad and type 2 error is good, but we have a misnomer that type 1 error is bad and type 2 error is good, as if you can accept some false hypothesis. It is not a very bad thing. So get sensitized with this about the selection of the level of significance. Then I told much about hypothesis formation. It is very important, because if you do not form the hypothesis properly, then post estimation it will create many problems, like whether you are to accept it or whether you are to reject it. Many problems will come in. Then another important point that is of interest is reliability and validity. Now, data set may be out of your stated preference. So, for example, I may canvas a questionnaire where I can ask you 100 questions, having some, asking you to give your preference in terms of Likert scale, whether you are satisfied or not. Suppose you are a tourist and I am asking you to give your preference of accommodation, whether you agree with a good accommodation or you doesn't agree with a good accommodation, that kind of thing. Now, that particular data set must be reliable. Unless and until the reliability is checked for that data set, that is not being applied. Now, how to check the reliability of the data set? You have there are different methods of checking the reliability, but most important is the reliability. You can look into by looking the cross correlations between variables, and then you are coming out with an average number, that is Cronbach alpha, and that should be above 0.7, rule of thumb basically. So reliability is done by looking into, say for example, I'm giving you that idea because, say for example, you ask me how much do you like the teaching of this particular college. You are saying that I am fully satisfied with the teaching of this college, 5 upon 5. How much you are satisfied with the infrastructure of the college, 5 upon 5. How much you are satisfied with teachers of the college, 5 upon 5. But how much overall you like the college, you are giving 1 out of 5. Then that data set is not reliable, because you are contradicting. You do not have coherency in your responses. Your responses are not coherent. So you will have to locate it by looking into the cross correlations. 1 with 5, 5 with 1, 1 with 5, 1 with 5, 1 with 5. With all those cross correlations, take the average. That average will be quite less. But if I gave you 5 upon 5, 5 upon 5, 5 upon 5, and lastly 4 upon 5, then your cross correlation average will be quite high. It will be more than 0.7. The data set is reliable. So that is very fundamental. One has to look into the reliability of data and the validity of your tools. What kind of, there are different validity, construct validity, ecological validity, various validity concepts are there. I'm not going to discuss because that will be again a kind of research methodology workshop. That's a big one. So I'm just going to sensitize you that these are the things. Then there is another major issue that generally comes in is the tasking of indexing. Say for example, you are dealing with time series data of GDP. So now GDP series will have to be deflated, because in 1950 you had a small number. Now in 2020 you have a high number, huge number. So you cannot compare. So what we will have to do, we will have to convert the real number, the money income into real income. So we'll have to convert the nominal GDP into real GDP. How the process is with the help of index number. We'll have to deflate the cities. Now there comes many troubles, because sometimes what happens, you do not have the proper deflator. You will have to select the proper deflator. Deflator is what? You can have your own deflator. P1 divided by P0 into 100. That is your deflator. Okay, current price index divided by base price index multiplied by 100. That is your deflator. You multiply with all the numbers, you get a real series. But the problem is that how to select the deflator, how to select the price index. You have different price indexes. You have different price indices for agricultural commodities. You have price index for wholesale commodities. You have price index for retail. You have price index, and many things. Now, which one to select for this particular context? So that is a $1 million question. The researcher will have to answer it properly first. Then you will have to go for this. The second point that comes in, you do not have a time series of that long period. So you have the problem of base shifting. So that base shifting process will have to be followed properly. If you do not follow the base shifting process properly, then the whole process of conversion from a nominal series to real series will be lost. It will be misled. So this is very important in the context of time series data, and normally we have. So sometimes what happens, I sometimes wonder while looking into some practical research, that we simply say that what was your income? Some normal questions. What was your income before you opened up this particular industry? And second question, the researcher asked, what is your income after opening the industry? So the respondent replied that what my income was 2000 before opening the industry. Now my income after opening the industry is 5000. Now researcher say that yes, so this industry is very good because it has generated 3000 incomes. But it is not like that. It is not like that. First, two problems are there. First, whether the time gap before opening and after opening is equal for all the respondents. That is the first thing. Number two, whether in between some other policy interventions from the government or some other things are there. You will have to keep the other factors constant. Number three, the third and most important point is that whether have you gone for deflation, whether you have deflated the series. If you have not deflated the series, that will be misleading. Say in 3 years back your income was this, your price level was different. Now after 3 years your income is different, your price level is also different. What is the real income gap? So you'll have to identify it. So indexing is something is very important whenever you have reference to time, whenever you have data with reference to time. Then another problem that in my mind is the missing data problem, particularly for our state. If you like to carry out this study, you will get missing data, particularly during 80s, early part of 80s, you get some missing series. So how to fill up that gap? Okay, if you are looking into time series, so that will happen. Even if you look for some other variables, then missing data will create some problem. So you have some standard statistical interventions like interpolation or extrapolation in order to fill up the gap of missing data. So you can have some response towards that. Some statistical interventions can be done, but if you try to fill up that particular data arbitrarily, then you don't have a theoretical base to answer. So I suggest that missing data should be filled up by some kind of statistical construct, maybe in terms of some interpolation, or in terms of you can go for a regression, and then you fill up the you can set the trend and accordingly you fill up the missing data. All those kind of things you can do. Then another happens that we do not look beyond numbers. We look what, and we don't answer why. Suppose sometimes it happens that someone's income is very less, reported less. And in our socioeconomic survey, we generally are interested in collecting the figure for income. Now, it may so happen that people do not have a very clear-cut idea of their income. What constitutes income, particularly in rural areas? I mean, someone may not consider agriculture as income. I mean, whatever he or she produce. So you will have to have a proper understanding that why that figure has come, why the income of 2000 has come, why not it is 5000, why it is 2000. So in order to have that that visualization, one will have to look beyond what, you'll have to answer why. So, but in data set, so simply in social science research, data of what is the data, that is not important. If someone report me that it is 50, that is nothing. It is lame in front of me. You'll have to answer together why it is 50. Is it rational, or is it justified to take 50 in this particular place? Yes, then you can just carry on. Then another issue is that we do not define the problem well. Definition of the problem, the research problem, has to be defined in proper parlance. If we do not define the research problem in proper parlance, then data cannot help you in guiding you to find a suitable answer for the research problem. So we do not have proper problem definition at the beginning in many cases, and ultimately that results in some of the cases where we do not come out with some perceived conclusion. Then another problem is the outliers. As you know that in some cases outliers create many problems. So for example, you are looking into incomes of the respondents. One outlier has come, income is crores and crores and crores. I mean, it's quite large number. So now all the points are, points are there in a linear fashion, but one number is quite in a quite outside. Now, if there is a possible risk, if you take a regression, then it will not show the general tendency of the data, but it will pass in between the outlier and your general trend. So it will create a different kind of things, because you will project something differently, you will estimate something differently, but normally it doesn't happen. So outlier will have to be treated, will have to be do away with by following some statistical procedure. So there are standard statistical procedure that you'll have to do. You'll have to deal with the outliers. Outlier also creates problem even in case of mean. Even in case of, say, the geometric mean, in case of standard deviation, your outlier can create different stories. You can have different stories because a single outlier will give you totally a different, understanding. So the process of treating outliers will have to be very clear in front of the researcher who is going to have that kind of statistical analysis. Then another very interesting point in my mind is the sample size. Majority of our researchers in social science research are interested in understanding the sample size. There are so many literatures are there in how to determine sample size. Normally, what happens, we look into the population size, we look into the different aspects, and then we take. But what statistics say, how define sample size? People have a very wrong notion that if the population size is large, then sample size should be large. But theoretically, though it sounds good, but practically it doesn't happen so. Because, say for example, if you go to the grocery to check the quality of rice, then we take handful of rice. It doesn't matter whether the bag is full or bag is half full. We take a handful of rice and then we infer whether you want to purchase the rice or not. And similarly, if we want to, see something, the average age of the students of your degree third semester, Then you take 1 or 2 students, take the average age and then you report it. So what matters is the variability of the population units. If the variability is less, then we require less sample. And if the variability is large, we require large samples. So for example, if someone asks me, what is the average age of the students of master's class, then I know that all of them are of the same batch. So I will tell 1 or 2 students will come and then report the age. Then I take the average and report safely that it is 20. But if someone asks me, what is the average age of your PhD scholars? Say we have 20 only PhD scholars, but someone may be quite old, someone may be quite young, someone may be in between. So I will now not limit the sample size in 3. I will have to increase it to at least 6, 7, or 8 to get the average age of the PhD scholars. Mind it, the size of population is less in PhD in comparison to my masters, but the variability is quite high in the second case and variability is quite less in the first case. Now think of a situation where you do not have variability altogether. All units are of same value. Then single sample will do. Only one sample will do. You do not require to collect more sample than one. So this is what actually the major issue. What we are interested in understanding is sampling distribution. The most important term for a researcher, to look at the sampling distribution. And what we are looking into? We are looking into the variability of the sampling distribution. What is that? That is nothing but the standard error. So we look into the standard error in determining the sample size. That is a more precise way of looking into the size of the sample. Precise way to locate the size of the sample is to locate the standard error. And if standard error is large, obviously the variability in the sampling distribution is very large. And if standard error is less, the variability in the sampling distribution is low. So always look into the standard error. And if all units are of same numbers, then obviously your sample distribution, it will collapse in a single line. So ultimately standard error will become 0. You don't have to go for sample size more than 1. So this is very important. So that's why generally we carry pilot survey, we calculate the standard error, and accordingly we fix our normal activity of collection of data. Then another issue is that we always should be sensitized about the problems of ordinary least square. Why I am mentioning ordinary least square? I could have mentioned some other methods of estimation also. But because ordinary least square is most common, widely used method in statistics and data processing in social science, that's why I have mentioned about OLS, the regression technique that we generally use. So there are lot many problems associated with OLS, depending upon the unfulfillment of the assumptions of OLS. Say it may start from error term being homoscedastic. Error term is non-autocorrelated. Then it follows normal distribution. Then the mean value of the error term being 0, and so on and so forth. So if you do not possess, if your data set do not possess those properties, those assumptions are not fulfilled, then it is risky to go for OLS. So we will have to be extra serious about the assumptions of OLS, and some problems associated with OLS. It is not simply the assumptions that give you a full correct model, but there are some issues which will have to be looked into. One is errors and variables. Then you have specification of the model. Those things are also equally important. Similarly, you have to have extra caution when you go for time series modeling and panel data modeling. When you are handling time series and panel data, you should be equally careful whether you have some kind of linear trend or you don't have linear trend. Depending upon that, your model will define. Your model will be defined depending upon whether you have stationarity of variables or whether you have non-stationary variables. So depending upon that, your models will be selected. So similarly, in case of panel data, different problems are there, and accordingly, you have to follow the steps. So my understanding is this, that in case of OLS, because OLS is mostly used, we will have to look into the assumptions of OLS, and we'll have to see whether the assumptions are fulfilled or not. And if the assumptions are not fulfilled, and if we have some miscellaneous problems associated with the regression model, then immediately some corrective techniques must be followed. And we should not use OLS directly in that particular context. We have some more methods in place. It's not simply that we will have to look into OLS. We can go for MLE, maximum likelihood estimation, or we can go for weighted least square. In case your disturbance sum suffers from different problems, you can go for weighted least square. That may give you some robust estimates. That can give you some kind of blue estimates. So we will have to look into the context. We'll have to look into the assumptions, and we will have to look into the possible consequences of running OLS in that particular system. But as data analysis is art as well as science, we will have to be more rational in selecting the whole issue. So for example, in multi-collinearity, we should not be overreactive. If VIF for a particular variable comes to be more than 5, you should not be overreactive and discard everything and then move to something else. We will have to see whether that is my purpose of looking into only the multi-collinearity issue here. If not, if we are interested in looking into some other things of that particular regression, then maybe a VIF marginally higher than 5 may not create that much of problem, that much of trouble. But so it's a kind of art. You'll have to select your own architecture. You'll have to select your whole, world where you want to move. It's science in the sense that tools and techniques and everything is there, and these are scientifically tested. But how you are going to apply it, that depends on your real life situation, that depends upon your rationality, that depends upon your judgment, and that depends upon your understanding of the problem. So problem must be clearly defined, and accordingly you can come out with some real life situations. So we have some misnomers regarding your model fit also. We run the regression, we run the OLS, and at the end of the day, we come out with R square and R bar square, coefficient of determination and adjusted coefficient of determination. Enough literatures are there that we have some problems associated with R square. I'm just giving you one example of R square. The problem is this: if you add a new variable to the regression model, R square will never decline. Either it will remain same or it will increase, but it will never decline. But what will happen if you add a particular variable to the model? Your degrees of freedom will decline. And once your degrees of freedom declines, your precision of the estimates will decline. Your model doesn't have that much of merit that you had earlier. So in order to adjust the degrees of freedom in the model fit, then you have adjusted coefficient of determination. Similarly, we sometimes ignore the F statistic, which we should not have ignored. F statistic is very important, and F must be significant in a particular regression model in order to just move further. Because what is F? F is nothing but whether all regression coefficients are all at the same time equal to 0 or not. So it is quite fundamental. If your F is not significant, how can you proceed further? You cannot proceed basically. So we will have to look into everything of a regression, and the things those are reported by the computer programs, any kind of computer program that generally reports all those kind of things. But we have another craze for running computer things. But we will, at the same time, I request the young learners only to look into the estimation techniques. How basically the estimates are carried out. How we generally go for estimation technique, unless and until we know that your computer, if you run everything in computer, you do not get that much of pleasure of deriving the estimates. You can have the estimates at your disposal directly by running it in computer, but you do not have that much of understanding as well as pleasure. Econometrics and data handling is something where you should derive pleasure. It should not be very compelling and very disturbing for a young researcher. Unless and until you derive pleasure of handling data, unless and until you get interest in running the estimates, this is in fact not the right time for you. So you always, as a researcher, should try to get that kind of understanding, that kind of experience, that kind of exercise in order to get some pleasure in data handling and data analysis. That is the most important point that a researcher should keep in mind, that when it is becoming more tedious, when it is becoming more compulsive on my part to do something, then it is not actually the right time to handle data. So when you feel that it's something pleasant, whether you feel that it is something refreshing while I'm dealing with the data, then it is your time. Then carry on the exercise and you will have meaningful exercise then and there. So with these words, I would like to conclude my brief presentation on data analysis and the caveats of it. And now I thank the organizers for giving me the opportunity, particularly the principal, Dr. Mohanta, the organizers, Dr. Surajit Soikia and his team, the colleagues of all faculty members, esteemed faculty members of Gargaon College, and other learned participants for giving me the time. Thank you very much. Over to Surajit.
Thank you, sir, for your nice and impactful presentation, sir. Sir, we have some questions. Would you like to take it?
Yes.
Okay, sir. Sir, question asked by Surabhi Datta. Sir, can you please suggest some methods to remove outliers in the data set? Which method is suitable, sir?
Yeah. No. See, there are different methods. Sometimes it is not that always you are to remove the outliers. There are some things that where you can work with methods, with outliers also. See, you can look the structural breaks, whether if in a time series, it's a very long kind of subject, that's why I don't like to move. Because if it is a time series data, then say an outlier, you can look into whether a structural break lies before and after that outlier. And then accordingly, you can model the things. In time series, you have models with outliers, model with structural breaks, model without structural break. So it depends upon the context. Sometimes you will have to remove it. Sometimes you will have to smooth it. Sometimes you will have to work with the outliers. It is not that always you are to remove the outliers.
Another question, sir. From Manoranjan Gogoi.
Yes.
Sir, suppose I have a cross-sectional data set on a particular agricultural production and trying to estimate its production behavior and its export efficiency. Now, what kind of production function or regression will be more fruitful to estimate it? It will be based on previous works or have any other identification technique for the estimation to select the technique. For that estimation to select that technique.
Okay. The information
Would you like
that
to
I
write all the questions, sir?
yeah.
Would you like to write all the questions sent by the participants?
No. I'm just giving you the answer for
One by
this.
one. Okay, sir.
Yeah. Now, what I could gather the information from this particular question is that you want to run a production function. For production function, you don't have any issue because you have the standard production function literature altogether, and you have the production function for Cobdo class, or you can have the Cobdo CES or BS, that kind of frame you have. So you have, but I couldn't get the question in clear tone. Probably you want to know production behavior and export performance, isn't it?
Sir?
Production behavior and export performance.
Production, agricultural production behavior and its export efficiency, sir.
Export efficiency. Yeah.
Oh.
So production, so you want to have export efficiency as outcome, I mean dependent, and production behavior as the production outcome as the independent. Probably that is what you are looking into. So if it is a time series setting, then obviously the time series methodology will have to be followed, either ARDL or something. And if it is a cross section, then obviously you can go for any linear regression. What I understand, if that is my understanding is correct, that export efficiency depends on production performance. So obviously, if you like to have that kind of thing, then cross section, then obviously you'll have to look into a linear kind of thing. But normally export efficiency, when you have the macro series, then better to go for time series data. So if you look into time series data, then obviously I will suggest that you first check the stationarity and all, then go for ARDL or whatsoever the model comes, you follow accordingly. Standard protocols must be followed. Next.
Another question from Ranjit Khonikar. Sir, is there any mathematical or statistical formula of determining an ideal sample size using the variability and population size, etc.?
Yes, Ranjit, there is no formula for encompassing capital N normally. Theoretically, it cannot be, but there are, I don't say that without capital N, you don't get a particular formula. There are, but mostly, most celebrated, the mostly accepted theories, mostly accepted formulae, generally do not take capital N as a factor in determining small n. But there are some formulae which takes care of capital N. But if you like to have small n determined, you look into the standard error of the units, population units. You look into it, and there are n number of formulae depending upon the level of significance, the error you want to commit. Depending upon the error you want to commit, so you will have to fix the interval, and accordingly you look into the standard error of the estimate and then find the sample size. N number of formulas are there. You can have it.
Last question, sir. Smritimay Sharma from Smritimay Sharma. Sir, in case of large sample size, which parametric test will be most appropriate for analyzing data?
Okay, now it depends upon context to context. I mean, analyzing means what? Basically, if you like to compare means, then obviously I'll suggest T. And if you like to go for something, association of attributes, then I'll suggest something different. So large sample means basically it is not that clear what kind of analysis you want to have. If it is regression, then you go for OLS. And then if it follows normal distribution, then T can be applied there. So size is one and estimation technique is one, depending upon the context you want to have. Suppose you want to compare the means, one particular method will have to be applied. If you want to compare, if you want to look at the factors that determine the behavior of the movement of a particular variable, then regression will have to be applied. So depending upon the context, you'll have to select the method.
So these were These are the questions, sir. Thank you, sir, for your time with us. You have given, you are very busy in these days, we know that. So thank you, sir, once again from our organizing side. And your presentation is very impactful to us or to the participants to hope the about the.
Surajit, I'm just sensitizing because
Okay.
because you have a young team of researchers of social scientists, particularly from Assam. I'd like to give you one food of thought. One important thing is this: we are doing the research in the stereotype setting. Okay, till now we are doing all studies, particularly in stereotype setting with simple regression and all these kind of things. But I urge upon you to look into, you break the boundary and enter into some more interesting areas, because now post COVID things will now get changed. You know, that simple kind of time series, simple kind of cross section analysis, all these things may not happen because new things are coming up. So some kind of new domains you bring, like, you know, now people are looking into big data in a different way. So data science is coming up in a different way. So why not we can work on it, artificial intelligence and big data. And at the same time, say neural network has come. As you work on artificial intelligence, so neural networking is a big taking big space in our studies. So I urge upon you to look some areas where you can take at least neural network and artificial intelligence in understanding the economy or the movement of the economy. That's it. Thank you.
Thank you, sir. Thank you, sir. Once again, from our side. Sir, your presentation was awesome and very impactful to the participants as well as to us also. Your presentation on data analysis, about regression, about different methods of regression, about hypothesis testing will definitely help us to apply in our practical research in for the participants too. They can use these concepts in their research works. Thank you once again, sir, for your valuable time. We know that you are busy in these days. Your schedule is very busy. So thanks once again. And I would like to thank you all the participants for their interaction, active participation, and patience. Hope we will meet tomorrow in the same time. And now I'm going to conclude this session. And thank you once again to you all. Thank you, sir.
Thank you all. Thank you.